So today is going to be our introduction to vectors. Now some of you might have talked about vectors if you've had physics, so this might be a review for you, but some of you this might be brand new. So what exactly is a vector? A vector is a quantity that has magnitude and direction. So a lot of times we'll talk, if we're talking about driving a car, you're driving 55 miles. But if we add some direction to that, you're driving 55 miles in a northeast direction, then you have a vector, because our magnitude, how far we're driving, 55 miles, and then that direction as well. And in math, we're going to represent magnitude, or represent vectors with an arrow. So we'll have the tip of it as well as the tail, and we can figure out the length and the length of it as well as the direction. So we'll be using some of those trig skills that we've been working on the last couple chapters. So each vector has an x component and a y component. So this vector here, the x movement, it moves over 3 and goes up 3 for the y. So this vector would be written as 3, 3. Another vector, let's see if we start it here, and let's say we go, this isn't too straight at all, but down to here. If we were to make that right triangle, and we could make it on either side, this vector, we'd say our x goes backwards 2, 1, 2, 3, 4, and down 4. So the vector would be written -2, -4. Or sometimes you might see it written horizontally as well, and it's written as -2, 4. So it looks much like a coordinate, like a point you're going to graph, but it has those arrows instead of parentheses. So a couple things here, just to clarify again, that magnitude up here, that is the length of our vector. So whenever we say magnitude, that is referring to the length. And when we talk about the direction, that is always between the positive x-axis and the vector, the angle there, the angle that is formed. So if we go back up and we take a look at these, let's change the color here. Here is our positive x-axis, so the angle of this vector would be that measurement, so something over 180. Whereas this one right here, here's our positive x-axis, here's our angle, so that one would be less than 90. And a couple extra vocab words. So this first one right here, 3, -2. So now vectors can be drawn anywhere, but if a vector is a position vector, that means it starts from the origin. But we're going to look at some vectors and we can draw these anywhere. So this first one, 3, -2. So if it starts here, that means our x, it goes over 3 and down 2. So our vector would be right there. Unit vectors. Unit vectors have length 1. And it just means I stands for our x movement and j stands for our y. So if we look over here, this is like saying we go over 3 vectors length 1 and we go down 2 vectors of length 1. So in unit vectors, this would be 3i plus 2j. Excuse me, that would be minus 2j. Now if you need to find the magnitude, you guys should recognize right here these are right triangles, so we could use the Pythagorean theorem. And magnitude is denoted with absolute value signs. So our magnitude equals the square root of whatever 3 squared plus -2 squared. So our magnitude equals the square root of 13. Parallel vectors. A parallel vector means that it is going in the same direction. So a parallel vector for this, I could say a parallel vector would be 6 and -4. Because if we went over 6 and down 4, it's still going in that same direction. So it's always going to be a multiple of your x and your y. Negative vectors means it's going the opposite direction. So our vector for a negative 1 would have to be going backwards and up. So that would be negative 3 and positive 2. So let's look at Q. So we go over 1 and up 4. So we have our vector right here, so 1 and 4. So that means I is our x value, so we go over 1i and up 4j. So our magnitude of Q, again denoted with those absolute value signs, we got 4 squared plus 1 squared, the square root of that, so that would be the square root of 17. One parallel, we could multiply both those by 3 or 4, it doesn't matter what the number would be, so 2, 8 would be one that's parallel. And negative, so we'd have to go backwards 1 and down 4. And then our last one, we have negative 2 and negative 5. So that would be negative 2i minus 5j. So magnitude, using those absolute value signs to denote that, negative 2 squared plus negative 5 squared. So 25 and 4, so that means our magnitude is equal to the square root of 29. One the same direction, let's triple it this time. So we'd have negative 6, negative 15. A negative direction, so going in the opposite direction, 2 and 5. Because then we'd go over 2 and up 5. And then down here at the bottom, we have Q minus P. So when we do this, Q minus P, so that's saying we have 1, 4 minus 3, negative 2. So all we have to do is subtract our x components and our y. So 1 minus 3 is negative 2. 4 minus negative 2, that turns into 4 minus a negative, so add 2. So that would be negative 2, 6. So now we have P minus Q minus R. So 3, negative 2 minus 1, 4 plus our R of negative 2, negative 5. So again, we need to take our x component. So 3 minus 1 is 2, plus negative 2, or excuse me, 3 minus 1 is negative 2, plus negative 2 is negative 4. And then if we take our y's, negative 2 minus 4 is negative 6, plus negative 5 is negative 11. 3 times vector q, so 3 times 1 and 4. If we were to draw this, so it means we go over 1 and up 4, over 1, up 4, over 1, up 4 3 times. So really, we're just tripling our x and tripling our y. So we have 3 and 12. And then the last one, p minus 2r. So p is 3, negative 2, minus 2 times our r of negative 2, negative 5. So let's see, 3, negative 2 minus, if I double r, we'd have negative 4, negative 10. And then once again, if we take our x's, 3 minus negative 4, so that's really 3 plus 4 would be 7. And then we take our y's, negative 2 minus negative 10, so negative 2 plus 10 is 8. So the very last thing we're going to talk about is vectors in 3D. Because we won't always just be drawing vectors on paper, but we'll be doing vectors in 3 dimensions as well. So instead of x, y, we have an x, y, and z. or you'll see them as X, Y, and Z. This should have those brackets there. So let's say given coordinates, so if I ask you to find vector A, B, and A is coordinate 0, 2, 0, and B is coordinate 3, 0, 2. So vector A to B, so we're given coordinates and we're asked to find the vector. To get from 0 to 2, we go up 3, 2 to 0, we go down 2, and 0 to 2, we go up 2. Well, that's going to differ if I would have said find vector B to A. 3 to 0, we go down 3. 0 to 2, we go up 2. And 2 to 0, we go down 2. So direction does come into play. And then if you were to ask to find the magnitude, again, those absolute value signs meaning magnitude, we have to do that Pythagorean theorem. So we have the square root of 3 squared plus negative 2 squared plus 2 squared. So we just extend it. And instead of x and y, we have the x, y, z's. So that's 9 plus 4 plus 4. So 13 plus 4 is 17, so it would be the square root of 17.